Welcome to IGCSE Survival Kit by AZ. Subscribe now and survive IGCSE. All know that you have Physics Paper 6 exam coming up soon. Today we will be discussing and going through some of the resources. Okay, so this is, first of all, we'll be starting with ATP analysis by Vasu Mitra. He's one of the most IGCSE saver, he's literally the goat of IGCSE. Anyways, so why take 5 readings and divide by 5 instead of taking 1 reading? The reason is that time errors due to human reaction have less effect. You can also write that reduce effects of error in starting and stopping stopwatch, because when you will get more readings, any error can be excluded more easily. Next, how to obtain more reliable readings? You should repeat and average. You have tried this in every 6, 7 or 6 marker. Do not forget to write this. It can get you just 1 mark for free. And remember, for reliable readings, you need to repeat and average. Simple. What do you want to suggest when you want to suggest a relationship between two qualities and want to justify them within limits of experimental accuracy is the word that you will be using. Okay, you need to write this. When they ask you to explain, you can write this. All right. Next tip for 7 or 6 markers, do not forget to write plot a graph, okay, whenever possible, and repeat and take average. This will just get you 2 marks for free. All right. And then repeat for at least 6 values. You can also mention that, and always write units when drawing the tables. Of course, units are very important. Also, even in answers, the units, many students tend to forget it, so please do not forget that. Now, how to answer, explain to how to use readings to reach the conclusion. So, of course, again, plot line graph with axes specified. That's a very good way. Another thing you can do is compare the readings in the table. Okay, you can write this. They can ask you how you can use the readings to reach a conclusion. So you can write compare the readings in the table to see if this factor produces a change in that factor. Don't forget what is independent variable. Independent variable is what you will change. All right, and dependent variable is what you will be measuring. Okay, measure. So I tend to remember this by this is independent, right? In chaos diaper mama. That's a very weird way, but this is a good way, technique to remember it. Okay. Now, next, how to accurately measure the volume. Of course, whenever any volume related question, don't forget to write bottom of the meniscus and line of sight should be perpendicular to the scale. Okay. This is a diagram to show you. This should be the line of sight perpendicular to the scale. You cannot. Okay, so you cannot measure it from here. You must measure it from the bottom of meniscus. That is from here. This is wrong. This is wrong. Okay, now next, how to measure the diameter of a rod. Use a rod between 2 blocks and measure the gap in at least 2 places, and then you can take the average. Like, you can use a rod between 2 blocks, okay, and then you can place the ruler and then you measure the gap in 2 places, and you can then take the average. This is the way you can do it. Or the other technique is use a micrometer, vernier calipers, and measure several points and take the average. Okay, then precautions while measuring volume of wood and rod. Wood might absorb water, yes, so measuring cylinder scale cannot be precise, right? Wood can absorb water. Like when you put the wood in the volume and you take the scale reading through your eye, and cannot be accurate because the wood can absorb all the water from the measuring cylinder. Okay, now moving on to the next, how to calculate gradient of a graph from, this is very important. So see, you are given a graph and this is the line, and they tell you to calculate the gradient. Okay, so draw a triangle as large as possible, then use the values and calculate the gradient. You can't just choose 2 values on your own and try to find the gradient. You are going to draw a triangle to show them that you're choosing these values, okay, and try to take it as large as possible. Like if if this is the line, don't just take it this, try to take it as large as possible. All right, okay, I hope you got it. Next one, yes, how to take gradient is done. Okay, why is it useful to take a trial reading for experiment? To check if this reading is measurable, to check if independent value is appropriate. Okay, so now why is it useful to take a trial reading? Basically, what is a trial reading is a practice test. Okay, it is sorry, you have to deal with my handwriting. Okay, it's a practice test which you do basically before starting the experiment. Okay, so in that practice test, you are able to check if the variable is measurable. Like if the dependent variable, what you're trying to measure, for example, if you keep a block and then you're trying to measure it, are you able to even measure it well? Or if to check if the independent variable, like if you're changing the temperature and if that is appropriate, and to establish a range of dependent and time values so that you can get like this can be the value. Like imagine you use a temperature that's 50 degrees Celsius and you're not able to get a good value. So basically trial reading helps you to identify your errors and mistakes. Okay. Now next, how to ensure if scale is horizontal. Measure if you want to check if scale is horizontal. So this is a very repeated question. If you have a ruler and it is placed on a bench and you need to check if it is horizontal, what you're going to do is you're going to take two rulers and till the bench top, like till the bench point, and you will measure the distance among of these two rulers. Okay, two vertical rulers to check this if this rule is horizontal. If this, like for example, take this as m1, this as m2, or L1 and L2. So if these two distances L1 is equal to L2, it means this rule is horizontal. So that's what this is all about. So see, measure the distance of rule from, this is from, okay, from bench at two ends and adjust if until equal, horizontal if it's equal. Okay, now it is sometimes difficult to position the load on the scale of the meter rule. Of course, like this is the meter rule and it's difficult to place the load on top of this, and it's of course on a pivot. At the correct distance from the pivot, suggest one change to the apparatus to overcome this difficulty. Mark the center of line. You will basically mark the center of line of this mass, okay, and you will suspend the load from a thread, all right, and then align it with the mark on the rule, and then you'll find where the mark is on the rule, and then you will align the center of mass with that point. For example, you have to keep it at 2, and then you will take the load, you know its center of mass, you will take the load, you know its center of mass, and suspend it from a thread and keep it at that point too, so it's more accurate and easier to take. So that's what they have said it here. Suspend the load from a loop of thread and add 1.5 to 5 to find the position of the edge of the block. Basically, this is a technique to find the what? The center of mass of block. Okay, so next, mean value of marks at both edges of mass, okay, and then mark center of line and align with the mark on the rule. Okay, so all you can do for this question is just memorize this tricks and like understand it. Okay, how to measure the length or L of the pendulum. Okay, how do you measure this length? Okay, so what you do is measure the top of the bob and then add half diameter measured with blocks on the rule. And what you can do is measure the top and bottom of the bob, measure the top and bottom of the bob, and then you average it. Make sure that you view perpendicular to the scale, okay, 90 degree to the scale, okay, and then rule parallel with the string. Rule should of course be parallel with the string. Like this is the length L, it should be parallel with it to get the accurate measurement. Then keep the rule close to the pendulum. Of course it should be close to the pendulum. Measure from the bottom of the clamp from here, okay, don't start it from here, don't start from the top, it should be from the bottom of the clamp. All right, so that's what they're trying to tell us here. Okay, explain briefly why the position of the pivot may not be exactly at 50 centimeter of the rule. Center of mass is not of the rule is not at the center. This is easy. What they're trying to say is that why the position of the pivot may not be at the 50 centimeter of the rule, because of course, like this is a 100 centimeter rule, maybe its center of mass is not at the center, it's not at 50, it's somewhere here, so that's why the pivot must be at some other place. Okay, now what is the source of inaccuracy in this experiment? Test load not exactly at 1 Newton, like this test load they have not kept exactly at 1 Newton. Another can be that the spring extension is not linear, yeah, because when a spring extends, like, you know, it needs to be linear this way. If it goes like this, it's not a good way. Okay, the distance should be linear. And meter rule is not uniform. Of course, meter rule has to be uniform, it must be straight, it must be horizontal. Now moving on to temperature. How to get temperature reading from a thermometer as accurate as possible. You don't need to think much for this type of questions. You know, always remember points like keep hand side of the eye perpendicular to the scale reading, to avoid parallax error, stir before reading, because you know why we stir? If you stir before reading and then measure the temperature, the advantage is that everywhere there will be even distribution of the temperature. Okay, so it's not that one place has a high temperature and the other has lower, so your reading might be affected if you take it at different places. Now if container is present, then if it's a container, don't let your thermometer touch the sides of this container and the glass beaker or the container, whatever it is. Okay, it should not touch the sides of the container. Wait for temperature to reach maximum before reading. Yes, because that's very important, because then you won't get the accurate reading, right? Some of the mixture is still getting heated up, like by conduction or convection, and you start measuring the temperature, so it will not be accurate. Let it reach the maximum value. and then measure it. If comparing the temperature of some liquids in two identical beakers, keep the thermometer at the same temperature at depth. Like, of course, it should be at the same depth. Otherwise, if it goes deeper, maybe the temperature is high there, or there can cause be many errors and issues. What are the control variable when measuring the rate of cooling or heating in a beaker? Of course, you need to use the same volume of water. Okay, that when you put the beaker, it should be with the same volume of water, the same initial temperature. The surface area of container matters a lot, because according to surface area, it can lose different amount of heat or gain different amount of heat. It should be same diameter and height of the container, same room temperature, material of the beaker, and duration of the experiment. Please learn all these tips and points. How to prevent the loss of thermal energy from beaker? Of course, you can insulate it. You can put a lid on top of this beaker to prevent the loss of the liquid through evaporation. Then you can lower the starting temperature to get more range of temperature, higher the room temperature, and so that it doesn't lose heat to the atmosphere. Of course, when the room temperature is higher than this, so the temperature won't be lost from this, the heat I mean. Okay, so use smaller volume of water and smaller surface area. Okay. Now next, experiment of how lid affects the rate of cooling. Repeat same experiment without a lid first. If we are trying to check how lid affects the rate of cooling, you first do an experiment with the lid and then you repeat the same without a lid, okay? And then you calculate the cooling rate for both of them, okay? And then you subtract the cooling rate with the lid, okay? So you subtract the cooling rate. Now moving on to the next question. To the next topic, ray trace. Ray trace is very common nowadays in all the past papers. Make sure you do it very well. So what are the possibility of errors in ray trace experiment? That the ray has a fine thickness. Rays are not thin. Okay, rays are not thin. It should have a fine thickness. Difficulty to align the pins. It's very difficult to align the pins if you have done the experiment in lab or have seen someone doing it. If not, you can go up and search it and see someone do it. Okay, pins should not be too thick. Pins too thick, that can be an error. Inaccuracies have more effect on smaller angles. Okay, now the next part. What are the precautions in ray trace experiments? In ray trace experiment, you should use thin pencil lines. Of course, thin pins are very important, and thin pencil lines too. View the bases of the pins when the pins are kept, so you should view the bases, and there should be a large pin separation and ensure the pins are vertical. Again, use thin lines, bottom of the pins, ensure pins are far apart. Okay, now the next one, explain why 2.7 centimeter pin separation is not suitable. The reason is that it's too small. It should be as large as possible for greater accuracy, and it should be much larger, of course. Now moving on to electricity. I hate this. Anyways, what are some possible difficulties in resistance wire experiments? Difficulties to judge position of crocodile clips. Okay, difficult to measure wire to nearest millimeter. Like, it's difficult to judge the position of this crocodile clip, right? If it's here, it's difficult to judge the position. What if it's here or here? So in the position, it can be difficult to judge. Then difficult to measure wire to nearest millimeter, of course. Connect between wire and crocodile are not precise. Contact between is not precise. Like, some tangent can be more contact, less contact in each experiment. Then difficult to interpolate readings on meters between marks, of course. Now, if you replace a resistance wire with variable resistor, place the variable resistor in series. So this is something you all should remember. Resistor, okay, resistor, that is variable resistor, okay, variable resistor, and ammeter. Ammeter. They are always placed in series with the circuit, and the, what is it called? Voltmeter. Yeah, voltmeter. Wait, let me write it. Voltmeter is always placed in parallel with the circuit. Okay, between the points where you need to measure it. So please always remember it. What are the disadvantages of not using a variable resistor? This is a very common question to ask you. What are the advantages? What are the disadvantages? You cannot obtain a continuous set of value if they ask you advantage. Okay, you can just, okay, so we are not able to obtain a continuous set of value, and it is less straightforward to change the current, because in a variable resistor you can just change the resistance easy by varying the length of the resistor, right? You can keep it at this length, so you can change the current easily. So it is now more difficult because you have to keep changing the resistor, and of course you can't obtain a continuous set of value, and it is more difficult to obtain a greater number of values. Okay, now this is the last question of this PDF. They have just given for a lens experiment how you are going to carry it out. First of all, carefully look at this diagram, because they can ask you to draw the diagram. It's usually you may draw the diagram, okay, but sometimes it can also be a must. You must draw the diagram if you're very unlucky. Okay, so Just look at it carefully, and drawing the diagram can give you extra marks maybe. Alright, so first of all, you carry it in a darkened room. The reason for this is that you can see the image more clearly, and you should use a brighter lamp, and you have no other lights working in the room. Move the screen slowly to obtain the best image. You should move it slowly back and forth and check the position where you'll get the best image, the clearest and most accurate image. They also ask you that how can you improve the accuracy, and you can get an accurate image. So when they ask you this, you can include this point. Okay, so mark block to show the length of the center. Of course, you can mark the block to show the length of the center, like this block just kept over here. Wait. Okay, you can mark this block at the center to show which is the center of the lens. Then make sure they're all perpendicular to the bench. For example, like maybe the screen should not be tilted or something. It can cause problems. And repeat the measurements, of course, several times on average. So this is something you should always include. Okay, always include in your 6 markers to get good marks. Okay, now with this we come to the end of the Wisdom with Thru PDF. Let's go to our other resources. Okay, this is another resource I found online. It contains the same stuff. Let's just quickly go through this. For lens experiment, again, you carry it out in a dark room. Avoid parallax error when measuring the U and V values using a meter rule. So you should avoid parallax error. How can it be avoided? How can it be avoided? By keeping. So how can you avoid parallax error? You have to keep line of sight of eye. Line of sight of eye, okay, perpendicular to scale reading. Okay, to scale reading. So this is something you must do. Always mention this with parallax error. Okay, and then make sure screen is vertical using a set square. This is something very important. They can ask you how to ensure that the rule is vertical. Then you will say coincide with the set square and check if it is vertical, and then you come to know, okay, if the set square should coincide with the meter rule, so the rule is vertical. Then the center of the object, the lens and screen at the same height from the bench top. We already discussed this, and it should be perpendicular. All of them should be perpendicular from the bench top. Okay, just got too messy here. So now the messy. Okay. Now the translucent screen is always used to capture the image. Remember this. They always ask this. What can be an error? You can say that the hand is coming in between the ruler, so you can use translucent screen. This was asked, I think, in 2024, February, March. In the February, March. Okay, February, March it was asked. Now, the image on the screen is always inverted. Remember this? Okay, this is for the lens experiment. So please memorize all this. First of all, carry it out in a dark room. Avoid parallax error. Ensure that they are same height from the bench. And then use a vertical using a set square. Ensure that the screen is vertical using a set square. Use translucent screen to capture the image. And then the image on the screen is always vertical. Okay, now moving on to the next part. The glass and prism experiment. Okay, this is one which I told you is very common. Again, use sharp pencil, use thin lines. Okay, upper use thin pins so that the holes are small and it will affect the accurate construction of incident and emergent rays. Okay, and then use sharp pencil, thin lines. Spacing between the pins must be 5 centimeter, not less than that. Okay, it should be greater than 5 or equal to 5. View pins from their bases to ensure all pins are vertical. View pins through one eye so that all pins will appear as one pin, because even if you view from both your eyes, so it can come as aligned with each other. Electric circuit experiment, as I told you, I hate this. Okay, check for 0 errors in meters before starting the experiment. But actually this one, electric circuit, is very easy because they just tell you to read the readings and then you keep dividing and finding the resistance, and even the formula is given. So it's an easy question, marks gaining question. Okay, so now check for 0 errors in meters before starting the experiment. Like when you use ammeter, voltmeter, check for 0 error in that. Turn off the power supply between reading to reduce the heating effect on the wires. Of course, you should turn off the power supply, otherwise the wires may heat up and catch fire, which is dangerous to you. Avoid parallax error, again very common. Avoid parallax error. Tap the analog meters. Okay, limit the current to minimize the temperature. Of course, limit the current so that it cannot cause overheating of the wire. Okay, and okay, so all of this you need to remember. Let's go through them very quickly. 0 error in the experiment, and then turn off the power supply to reduce the heating effect. And then after that we have avoid parallax error, tap the analog metering, limit current to minimize the temperature. You can always talk about temperature. For example, turn off the power supply, limit the current. All of this comes in the temperature. Okay, next question. Heating experiment, my favorite. Place the thermometer 1/3 immersed in liquid and make sure it should not touch the sides of container. We have already discussed that. Use lid to control the heat loss. Why? Lid will prevent evaporation. Okay, that will prevent the evaporation. Then next you can say insulate the beaker using a suitable material, polystyrene to reduce the heat loss. Of course, so it will insulate the material. Then remember the word polystyrene, you can write it for any improvement, and even in your plan and experiment questions if a thermometer question shows up. Okay, then next we have stir the beaker to distribute evenly. Okay, view the thermometer perpendicularly again to avoid parallax error. If you notice, this parallax error is there in almost every question. See, avoid parallax error, and then here also, here it's not there. Okay, but here again is there, avoid parallax error. So this is something you can always write in your answer. Now pivot experiment, find the center of mass of the object if the rule is not uniform. The pivot experiment, right? That's one. Okay, so you find the center of mass of this object. If the rule is not uniform, the center of mass will not be at 50 centimeters. So this way you can understand the rule is uniform or not. Now for the graph, always make sure, okay, for graph, always make sure your axes are labeled. For example, if you have, like, you can say temperature over here. Okay, temperature per degrees Celsius. Don't forget to write the unit, write the full word. I'm not writing it here. And then over here, you might be having like what you're changing. Like you can change. No, here you would have what you're changing, and here you would have what you're measuring. So for example, if you're changing temperature, you might be measuring the thickness of something. Okay, so like that, you need to ensure that your axes are labeled. Then next, ensure that the graph covers more than 50% of the grid. Of course, like your line should cover more than 50% of the grid. And of course, if the grid is going way long and your graph just finishes here, that's not a good way to go about. Calculate gradient by triangle method, as I explained you before. Then draw triangle's length, half the length drawn. Okay, mark the origin 0, 0. If you're taking 0, don't think you don't have to mark it. You have to mark it both ways if you're taking 0. Now next, measuring thickness of a thin object. Okay, measuring the thickness of a thin object. How are you going to measure the thickness? Multiples can be measured and divided to find an average value. For example, to obtain the thickness of one page of a book, measure the thickness of 20 pages. Of course, this is easy. For example, you have a book and it has many pages. Okay, I'm really bad at drawing, but okay. So what you're going to do is you can use a micrometer screw gauge, or you can use a ruler, but the ruler, make sure to avoid parallax error and all that, and you can measure the thickness of these many pages. Now you are asked to find the thickness of one page. Okay, and if you find out the thickness of 20, if you measure the thickness of 20 pages and you get it as like 10 centimeter, okay, so what will be of one page? You can use this proportionality method. So 20x is equal to 10, x is equal to 10 over 20. Okay, so you get the thickness of one page. So this is what they're trying to tell. Multiples can be measured and divided to find an average value. And yeah, you can repeat this method several times and keep measuring for 20 pages again and again and dividing it. So you can get a average value, and then the values you can find the average. So for example, to obtain the average thickness of one page of a book, measure the thickness of 20 pages and then divide your result by 20. Now this we already discussed before. To measure the diameter of a sphere or cylinder, place it between two vertical blocks. Okay, and then take the difference between these two readings, x2 and x1, add edges of it, and you will get the diameter. Okay, now measuring the diameter of ball bearings. To measure the diameter of ball bearings, collect them in a row. If you have to measure it for many balls, so you will collect them in a row between two vertical blocks, and you will measure the total length. Again, x2 minus x1, you will get for all of them. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now you're found for 9 of them. So you can check the length for one block. You don't know what is the length, what is the diameter, and for 9 you know what is the diameter. Like for example, take it as 20. So then you will take 9x is equal to 20, and then x equal to 20 divided by 9. So this is how you go about. And now how to check the rule is horizontal. We have already discussed this by using sprint level. You will measure the distance between the bench top and should be same. And now how to check if rule is vertical by using set square. Put the set square so that one side is parallel to the bench and other is parallel to the meter rule, and if this coincides with the vertical edge, then it is vertical. And even by using a protractor, you can do like you can take the ruler and then place the protractor. If the 90-degree edge of the protractor coincides with the vertical edge of the rule, then the rule is vertical. How to measure the circumference of a cylindrical shaped object. To measure the circumference, you will wind a string 10 times and then unwind it and measure the length. So you will take this object, wind the string around it 10 times and then unwind it around it and then unwind it and measure the length of the string and then divide it by 10 because you of course wounded it 10 times, and then the spring should be thin, tangent and without spacing, and of course there should be no diagonal windings. You can add it here, no diagonal windings. Okay, because of course that will affect the accuracy if there's spaces, and if they're diagonal winding, then if it's like this instead of being straight. Okay. Now, what are the reasons for inaccuracy? Using a thick string, of course, it can give inaccurate. The marks are thick, the leaving space between the turns, and stretching of the string, and winding turns at angles. That is what diagonal windings. Okay. Then what are the precautions you should be using? The precautions that you should be using are using a thin string. Of course, thin marks, basically just the opposite. You should use thin marks, tangents, turns without spacing, turn more, take more, turn number of turns, and yeah, of course, take more number of turns. Make sure that the string isn't stretched. All right. Now, how to measure the volume? The following precautions should be taken into consideration. The measuring cylinder must be vertical by sitting on a horizontal bench, okay? And then you will, of course, read at the bottom of the meniscus, and the eye level should be perpendicular. And this is where you keep your eye level. Perpendicular should be 90-degree. Couldn't make it accurate here, okay? And then yeah, don't avoid parallax error. As I told you, parallax error is a very simple thing you can write for most of the questions and get marks easily. Okay, the reading should be at the bottom of meniscus for liquid, unless for mercury. Okay, please remember this. It should be taken at the top of meniscus for mercury. Okay, next. Dealing with experiments, a simple pendulum experiment to investigate the length and mass of the period of a simple pendulum. Okay, of a simple pendulum, use support, stand, string, two metal bobs of different mass, meter, rule scales. Okay, so basically you use this apparatuses to do it. You use a string, support stand, metal plates, pendulum bob. Now what is the procedure? Okay, what are we trying to do here? Basically we're trying to measure the effective length and mass on how the pendulum moves. So first we will change the mass and then the length of the string. So let's see how we're going to do it. Measure the length of the pendulum from the point of support to the center of the bob. Repeat measurements and calculate the average. Calculate average is very important. Repeat and average must be your best friend throughout the paper. Okay, measure the time taken for the bob to make 10 small angle oscillations. Repeat the measurement and calculate the average time. I hope you're getting it. You first measure the length of this bob. Okay, measure the length of the string, and then you move the pendulum. Okay, for how long? For 10 angles. So that makes 10 oscillations, basically 10 small angle oscillations, and then repeat the measurement and calculate the average time. Of course, you will repeat for this too, and repeat for the top step as well. Okay, and then you find the average. Work out the period time. The t is the time, okay, of the pendulum. This is the time needed for one oscillation. So basically you divide it. For 10 oscillations, what is the time? Then for one oscillation, what is the time? You will use the proportionality method I taught you before. Now measure the mass of the pendulum bob and repeat it. Now repeat to steps 1 to 4 using a longer pendulum length. Now you will repeat steps 1 to 4 using a longer length, and repeat steps 2 to 4 using a heavier pendulum bob, because length and the mass what we are trying to measure, and the same pendulum length as it was used in step 5. Okay, you will use the same length that was used, but you will change the mass. When you're changing length, you will not change the mass. But when you're changing mass, you will not change the length. Okay, now what are the precautions to improve accuracy or to give more reliable results? No air currents in the place. Take the time of the number of springs, then divide the time measured by number of strings to get t. Okay, easy. Repeat and take the average. Okay, of course, here what they meant by no air currents is that when the pendulum bob is moving, and if the air acts on it, that will cause it to move more further. Okay, so it will affect the accuracy of the result. Now repeat and take the average. Look perpendicular to the rule. Of course, we've already discussed all this. Use that square as horizontal reference. Meter rule should be close to pendulum. Measure the length of from the center of the mass of the bob. Okay, yeah, it should be from the center of mass of the bob.